Hello everyone, this is Mathematically Speaking and I am your host, Adam Allred. Now why start with arithmetic and measurement? Besides them being the first subjects of math universally, nobody learns algebra before they know how to add, and you can't add if you don't know what a number is. But it is a bit more primal than that. Like, why do we have a language? What compelled early humans to make the grunts and groans that are words? And I know it's a silly question, but the answer is that we had to convey information. Whether if it was factual information or it was stories. The same is true for math. This is why we have arithmetic. We needed a way to convey information without changing it. This led to a symbolic representation and then grouping those groups when simple things like rocks would not do. We still do this today. If I asked you how much money you had in your wallet, you would probably pull out dollar bills, because pulling out a bunch of pennies would be absolutely insane. And this transference of numerical information is why arithmetic is so powerful and necessary. And it makes sense as to why it predates spoken language. You don't need words to do that. It can be done entirely symbolically. This is why some people call math the language of the universe. Or they suppose that if we ever met aliens and we had to communicate, it would first be with math. Just imagine, you would start with a number, then they would learn a counting system, and you would build your way up. And it would take forever, and there would be some confusion why we started throwing the number 7 at them, and hope that they would understand what we were trying to do. But it would work, because we have always used symbols, and we can always use symbols. And now, the symbols back then aren't the ones we know today. There was no algebra, there was no calculus, there was no geometry. The first mathematics was counting. Counting is a natural instinct, with number sense almost being another of the 5 senses. We can see the groupings of things, and if the number is right, we can have a sense of how many there are. That usually stops around 6, unfortunately. This is beyond just humans, with other primates having the ability to count, and ants having a built-in odometer. There was a study where scientists adjusted the legs of ants and had them walk to a target and back. After training them to walk there and back, their legs were lengthened with stilts. With each increase, the ants overshot the target and undershot their starting position. The ants were counting their steps to their destination. That is because counting is a means of comparisons, needing to know how far away something is compared to where you are, needing to know how much food someone has or how fewer children they have. But when the grouping becomes too large, we need to group them up in a way that makes sense. This gives us different kinds of counting that we will get more into in the next episode. But this has stuck in our language. Arithmetic is part of how we communicate. We group things in a way that we can easily forego the counting, and that group becomes that single unit. But where does this ability to count come into human history compared to spoken language and printed language? Some of the earliest estimations of printing was in China in about 200 AD, and language was about in 3000 BC. The oldest evidence of human counting takes back to 18,000 BC. And this artifact is known as the Ishago bone, found in modern-day Democratic Republic of the Congo. It's a bone with scratches and distinct groups that imply the knowledge of doubling and halving. Some columns had scratches in prime-numbered groups, others had only odd-numbered groups. Some similar bones have found in other places with scratches in groups of 29, which we believe to be counting a lunar month, which lasts about 29.5 days. The Incas had a counting system that used something called quipus. I'm probably pronouncing that entirely wrong. Well, there were a series of strings with knots in certain positions and varying sizes that indicated different numbers. So although the Incans did not have any written language, they still had a rich understanding of number, because they had a symbol, in this case, ropes with knots on them. We will see these again in Egypt for the construction of the pyramids. Unfortunately, when Spain conquered South America, they destroyed the quipus. We're not really sure how they developed the system. Now we know that human history goes back past 18,000 BC. The first Homo sapiens can be dated back to about 315,000 years ago. So what took so long? Well, mathematics, like language and writing and culture, cannot develop extensively without stationary peoples, specifically without food. The sooner that a culture can begin agriculture, the sooner the higher level thinking required for mathematics can begin. And although the concept of number could exist well before the settling of humans, some would say we are born with it, the written language of math could not. We all know how hard it is to do any serious contemplation and thought while hungry, because all we can think about is the next meal. And on this show, I'm going to do my best to highlight the cultures that contributed to the development of math. But if I do not mention a culture, it's possible that we don't have evidence of early math there. And by the time that they they developed this math, other places could have been beyond that point. So the idea of number has to predate the Ishago bone. A bunch of scratches on a bone does not mean much if a vertical line doesn't represent the idea of one, which makes sense. Being able to count how many kids you have, or how many sheep, or how many soldiers in an army a general has, there is an important distinction made between the representation of a number and the number itself. One vertical line does not make the number 1. It just represents the number 1. The representation cannot be the same thing as the actual number. Otherwise, my collection of 3 rocks and my 3 scratches in a bone cannot mean the same thing. Rather, they both represent something that exists outside of the symbols. The location of this existence is where many people argue, but more on this later. So now we have food. We have a stable society, but now we have a need to keep track of crops, hunting seasons, how much time to allot to different tasks. We need a calendar that begins with the sun. Today we know that a year is 365 days long with 12 months and 52 weeks. This is because we use what is called the Gregorian calendar. And before this, Julius Caesar adjusted the calendar because seasons were not matching their calendar demarcation, with snowing happening in July, for example. So he created the leap year, making each year 365.25 days long, so that every 4 years you gain an extra day. Another change was made in 1582 by the Roman Catholic Church, Pope Gregory XIII. Instead of making every 4 years a leap year, only those years with first 2 digits divisible by 4 are leap years. So the year 2000 was a leap year, but the year 2100 won't be, because 21 isn't divisible by 4. To do this, they removed 10 days from the calendar, so after October 4th, when the change was made, it became October 15th. This adjustment made each year 365.2425 days long, which is very close to what we now know to be 365.2422 days long. Eventually we will need to change this again, but most major cultures use the Gregorian calendar now, but many of them adopted it at a different time. The total adoption took 3 centuries to accomplish and was not easy. There were riots and protests over the accuracy of these new calendars, and if they were based off cosmological cycles, then the calendar's accuracy is only as accurate as the methods used to measure them, and people didn't agree with this. They didn't like that it was arbitrarily being changed, because if it had to be changed again and again and again, the whole world could be thrown off. But why did it take forever? Well, because there were other calendars. It's sort of weird to think, because the entire world now operates on one single calendar, the Gregorian calendar. But at some point, every civilization had their own. They all started at a different year 0. The Chinese calendar, the year is 4714, and that was adopted in 1912. The Buddhist calendar, the year is 2560. In the Byzantine calendar, it's 7526. Ethiopian is only 2010. Hebrew calendar is 5778. The Holocene calendar is 12,018. And the Islamic calendar is 1439. But each of these calendars were all adopted at different points post 1585, when the Gregorian calendar was created. The United States didn't adopt this calendar until mid-1700s, but all these calendars have a different year 0, which all represent different important things in that culture. For example, the Islamic calendar, year 0 is when Muhammad got to Medina in Saudi Arabia in the year 622 AD, Gregorian calendar. So from here on out, any year I mention will be in the Gregorian calendar because it's the one we use. But in speaking of the history of a calendar, it's important to note out which calendar we're using. But why 365? How did we come up with that number? It was by shadows. Because with enough patience and time, if you put a stick in the ground and make a mark where the sun is, and each day you come back to this stick and mark where the sun is, you would notice that 365 days later, the sun would return to the same spot, give or take. India knew this, the Egyptians knew this, but they didn't have the mathematical prowess needed to come up with the approximations we have today. So they just took 365 days and they broke it into 360 days and then 5 days of celebration. 360 was chosen because it divides by 1, 2, 3, 4, 5, 6, 9, 10, 12, 18, 20, 30, 36, 40, 60, 72, 90, 120, 180, 360. Meaning that you take one of those numbers, multiply them by another number in that list, or by another number in that list. There's a specific one, can't be any number in that list, and you will get 360. Then since it divides by so many numbers, you can section up a year into segments that make sense. Again, arithmetic is grouping things into ways that make sense for us to understand. And to the ancients, the idea of a year was how long it took the sun to make its way around the earth and return to the same spot in a circular pattern. You know that the earth rotates around the sun as the entire solar system flies through the cosmos, and we know that the earth doesn't move in a circle, it moves an elliptical oval shape, but it isn't illogical to think that the Earth is a center, especially when you are an early mankind setting civilization up for the first time. So can you guess now why there are 360 degrees in a circle? If you said because that is the pattern of the sun was thought to move around the Earth and how long it took to do that, then you are correct. Congratulations. Now on to the names of our months. They come from the Romans, whose calendar started in March after their god of war Mars. This puts December at the 10th month where it should be. July and August are where they are simply because Julius Caesar wanted a month named after him and his father, but there's no numerical reason beyond that. The 12 months in a year is simply because 12 is the closest number that comes to 365 when multiplied by 29.5. which is the days in a month-ish. Now, a quick aside, this is another example of the need for counting. It'd be extremely arduous to keep track of days in a year by what day out of 365 days it was. Rather, we group the days into groups of 12. That's what we call them a month. And then group those months into groups of about 30, and then break those into 4 groups of 7.
The number that we chose to split up our years and months and days into in weeks, it doesn't actually matter. We could have easily done everything in segments of 10. Why a day is split up into 24ths, it just happened to be that there were 12 things in the Egyptian night sky when all this got set up, and changing it would be much more of a hassle than necessary. But there's nothing significant about an hour being a 12th of a day and a 12th of a night. It doesn't actually matter. It's a 10th of each day. The selection doesn't matter. The reason we still have it is historical, not necessarily mathematical, even though there is some math to justify it.
So the rest of the temporal units, weeks, days, second, minute, hour, are the way they are for mathematical convenience. An hour is defined as 1/12 of the day and a 12th of the night. 12 was simply chosen because of the same reason 360 was. It divides easily by many numbers, so it's a grouping that makes sense. This gives us 24 hours in a day. Seconds and minutes are in base 60, which I will talk about what that means when we get to ancient Mesopotamia. But why do we have 7 days in a week? 7 days is fairly universal, but the Romans had 8. The French had 10 after their revolution. One idea is that a week is a fourth of a lunar cycle. 7 days is about a fourth of 29.5 days, which this gives about 4 to 5 weeks per month. Now, there was the belief that there were only 7 celestial bodies, each of them given the name of a deity by ancients. However, our days of the week aren't the order that they appear in the sky if you have an Earth-centric system. If so, then the days would go Monday, which is Moon, Wednesday for Mercury, Friday, Venus, Sunday for the Sun, Tuesday, Mars, Saturday for Saturn. It is thought that what our order comes from the Egyptians, who associated each hour of the day with a deity. First assigned the numbers 1 to 24 to each planet, starting with the Sun, then Venus, Mercury, Moon, Saturn, Jupiter, Mars, and repeating the cycle. If you repeat this, you should land with Mercury at on 24. So that's 1 day. If the cycle repeats, then Monday gets the first hour of the next day. If you do this 7 times, you will land back on Sunday. This very simple number play is something we will talk a lot more about when we get to China and something called modular arithmetic. Now, while this number play and counting is simple compared to the mathematics we have now, that does not erase its importance. The understanding of multiplication, division, and remainder as concepts are very sophisticated ideas, and then being able to do arithmetic with just the remainder is the precursor of what we now call number theory, which is abstracted arithmetic. Groups of people who we think knew nothing and only spoke in grunts had mathematical concepts that most people do not ever see, only if they go to college for a degree in mathematics. Now, in the next episode, we will be discussing counting in different bases and the cultures that came along with those bases. We will extend this beginning of arithmetic into foundations of geometry and take a look at our first mathematical philosophical perspective, intuitionism. Thanks for listening. This has been Mathematically Speaking.